So last class we were talking about stoichiometry, and we finished up the unit with our unit test. We're going to continue on with stoichiometry, but now we're looking at molar concentration. So when we think about concentration, we're thinking about the amount of substance which is present in a given volume of solution. Now remember, we talked about solutions earlier in the course, and solutions consist of two parts: a solute, which is dissolved in a solvent, now solutions can be either concentrated or dilute, and we'll take a look at an example of two solutions. So we've got solution A and solution B. Both solution A and solution B have 1 liter of water. Solution A, we're making iced tea. So we're going to add 3 tablespoons of iced tea powder in the water. Mix it all up to make the solution. Solution B, we're going to add 6 tablespoons of iced tea powder. Mix it all up. So taking a look at these two solutions, we have the same volume of water. We've added, which is the water would be your solvent, but we've added varying amounts of iced tea powder. So which solution would be more concentrated? Well, looking at the solutions, if we have more solute in a given amount of solvent, then we have a more concentrated solution. So in this case, solution B is more concentrated than solution A. Remember, the solvent in both cases was the water, and the solute is the iced tea powder. So solutes are the parts that are being dissolved, and solvent is the part that is doing the dissolving. Now, talking about whether you've got a dilute solution or a concentrated solution, doesn't really give you precise values to work with in terms of solution. You can use them in terms of comparing two solutions, saying one solution has a greater concentration or is more concentrated than another solution, but it doesn't really give you a numerical value with which to work with. Let's see if we're going to write down. So concentrated solutions have a larger amount of solute dissolved in the solution than a dilute solution does. So in chemistry, we want to talk about solutions as being more than just diluted or concentrated, and we want to know what the precise value associated with a solution is in terms of its concentration. So in chemistry, the amount of solute in a solution is described using moles and is described with the number of moles of a substance. When we talk about concentration or molar concentration, we can also say molarity. What we're looking at is the number of moles in a given volume of solution. So we can do some calculations in looking at what the concentration of a particular solution is if we know the moles of the solution or the mass of the solute and the volume of the solvent. So our formula that we'll be using is molarity is equal to number of moles over volume, which can be abbreviated using the following symbols, where C stands for molarity or concentration, and N stands for number of moles, and V stands for volume. Now concentration will result in units of moles per liter. And we can abbreviate this with a capital M, which stands for molar. Our moles, our units are moles. Volume, the units for volume would be liters. So if you're not given liters in a question, you would need to convert to liters. So let's do a few examples. So our first example, we have a 250 milliliter water. If 250 milliliters of water has 0.75 moles of potassium chloride dissolved in it, what's the concentration of solution? So we're given the solvent and we're given the solute. We are given the moles of the solute and we're given the volume of the solvent. So we plug in our numbers into the formula. So C is equal to N over V. So 0.75 moles over 250 milliliters. Now remember, for our formula, we need to have our volume in liters. So we need to convert 250 milliliters into liters, which would be 0.25 liters. So this is a straight division. We go 0.75 divided by 0.25. We end up with 3 moles per liter, or 3 molar solution of KCl. Let's try another example. So our second example, if 25 grams of sodium chloride are mixed in 400 milliliters of water, what's the solution concentration? So in this question, we don't have moles, but we do have the volume. Volume, again, is in milliliters, so we're going to have to convert the volume into liters. But we will need to convert the grams, the mass of the sodium chloride, into moles before we can use the formula. So there's a couple steps that we need to do for this equation. We need to find the number of moles of the solute, sodium chloride. We need to convert the volume into liters. And then we can use our formula. So 25 grams of sodium chloride. We want to figure out how many moles that is. So we need to use our molar mass for sodium chloride. So 1 mole of sodium chloride. Look up sodium on your periodic table. You'll find that it has an atomic mass of 23. Chlorine has an atomic mass of 35.5. Add those numbers together and we have the molar mass of sodium chloride, which is 58.5. Plug in those numbers and we end up getting 0.43 moles for our sodium chloride, for our solute. We were given in the question 400 milliliters of water, so that's our solvent. So our next step is to convert 400 milliliters into liters. That would be 0.4 liters. So now we've got our moles, we've got our liters. We can use our equation to calculate molar concentration. So plugging those numbers in, we end up getting 1.1 moles per liter, or we could say 1.1 molar concentration of the sodium chloride solution. We're going to do a couple more examples. So our next example, what mass of sodium hydroxide is in 25 milliliters of a 0.35 molar solution of sodium hydroxide? So here we're given the volume and we're given the concentration, and we want to figure out the mass. So we'll have to do a couple steps here as well. So the first thing we're going to do is we're going to use our formula. Now instead of finding concentration, which we already have, we're going to use our formula to find the number of moles. Then we'll convert the number of moles into grams. So let's take a look at our numbers again. So what mass of sodium hydroxide is in 25 milliliters of a 0.35 molar solution of sodium hydroxide? Well, we also have to convert the milliliters into liters. So let's do that first. So 25 milliliters is equal to 0.25 liters. Remember, there's 1,000 milliliters in a liter. So in order to get your numbers, pardon me, so it should be 0.025. You divide, so to get your, to convert milliliters into liters, you divide your milliliters by 1,000. Okay, so we've got our volume and we've got our concentration. So if you're familiar with the triangle, you can always write your formula in the triangle. So here's concentration, here's moles, here's volume. So what we have is we have volume and we have concentration. So these two variables are right beside each other in the triangle, so that means we are going to multiply the numbers together. If your numbers are, or if your two variables are one's on top of the other, then that means you're going to do a division. So we're going to, number of moles is equal to C times V. Concentration is 0.35. And our volume is 0.025. And when you plug in your numbers, you're going to have 0.00875 moles of sodium hydroxide. So now we've converted, or we've got our moles. So now we need to convert our moles into grams. So we want to know how many grams of sodium hydroxide is 0.00875 moles of sodium hydroxide we have. So 1 mole is equal to, so again we need to know the molar mass. So using our periodic table, we can look up the atomic mass for sodium. Oxygen and hydrogen, adding them together, we'll have our molar mass, which ends up being 40 grams. So plugging our numbers in, so 0.00875 times 40, you will get 0.35 grams. So in order to make that 0.35 solution, molar solution of sodium hydroxide, we would need to dissolve 0.35 grams into 25 milliliters of water. Last example we're going to do is what volume of a 0.25 molar solution of calcium nitrate has 63.5 grams in it. So again, in this question, we have our concentration and we have our mass. So we're going to have to do two steps here again. We're going to have to convert the mass into moles, and then we'll use the formula to calculate the volume. So you can see a lot of these questions have two steps to them. So the number of moles of calcium nitrate is equal to 63.5 grams of calcium nitrate. Molar mass of calcium nitrate. So again, you're looking up calcium, nitrogen, and oxygen. There's one calcium atom in this compound. There are 2 nitrogen atoms in this compound, and there's 6 oxygen atoms in this compound. So you need to be really careful when you're calculating the molar mass. On the stoichiometry test, not a lot, but a few students made some minor errors which affected their answers because they hadn't calculated the molar mass correctly. So you do want to be careful about calculating the molar mass correctly. So for calcium nitrate, the molar mass of calcium nitrate, when you calculate it out, is 164.1 grams. So when we plug those numbers in, we get 0.387 moles. So now we have moles and we have concentration. So again, looking at our equation, or formula, pardon me, you now have concentration and you have moles. So what you're going to do is you're going to divide the moles by the concentration, and that will give you the volume. Pardon me, got my variable symbols wrong. And concentration was 0.25. So plugging those numbers in ends up giving us a value of 1.5 liters. So you may have to do 2 steps with these questions, or you may be able to solve it in 1 step. So what you're going to do right now is you are going to write down these 2 skill testing questions, and you're going to show your work, come up with your answer, and then come up and show me what your answers are in your work. And if you've got your information down, you'll get your assignment for today. If you don't have your information down, I'm going to ask you to go back and retry the questions, maybe listen to some of the examples again. So thanks very much.